Hey guys, so welcome to your FVA AMD, and this is the first notes lesson. I think you'll see as we go through this course there's a lot of real life application. This first lesson is estimating crowds. Depending on what you're responsible for, what your job will be when you get older, you may or may not use this lesson, but you'll see that many of the lessons are very specific to everyone as far as being able to utilize, especially when we get to some of our finance lessons. So this first one, let's jump right in. We're estimating the crowds. We can see that the crowd conversion, or just a general conversion for anything, 1 feet equals 12 inches. So if you have 1 foot, it's going to be 12 inches, and you know that from the first ruler you got. 1 yard equals 3 feet. That's if you've seen a yardstick, which most of you have at this point, or you watch football and you see a yard, that's going to be 3 feet. And then 1 mile is 5,280 feet. All right, I like the Remember Titans quote if you remember that portion about him fumbling and then he has to run every foot of the mile, every 5,280 feet. All right, so use your conversions to answer the following. We have 47 inches. We want to know how many feet that is. So let's start what we have. So we have 47 inches. And then using our conversion, we are saying we know that we have 1 foot is 12 inches. That allows us to cancel out the inches. And then we have 47 feet divided by 12. And then if you did 47 by 12, you can do that in the calculator if you'd like, no worries. Then it ends with 3.9 feet. And to say 0.9 feet is okay, like there's no issues there. You can make sure that you've got that maybe a little bit easier to understand to say 3 feet 11 inches if you prefer, but either way it's going to be totally fine with 3.9 or 3 feet and 11 inches. Then our next conversion we have is our 10 yards. So with our 10 yards, we're going to see that we have 10 yards, and we want to know how many feet that is. This one's a little easier in the sense that when we convert, there's no fractions, so you would have 3 feet over 1 yard. The yards cancel out. 10 times 3 gives you 30 feet. All right, so that's fairly straightforward. And if you watched a football game there too, you see, okay, well, they got to gain 10 yards or they got to gain 30 feet. So when we are identifying what is a proportion, the proportion is taking two ratios, which are essentially fractions, and you are setting them equal to each other. All right, so if we're setting those equal to each other, then what we're doing there by setting them equal to each other is we are able to make a comparison. That's what we're trying to do with our proportions. So let's look at our first one. We're saying there's a jar, which basically would be this. This would be the larger of the two, but it is going to be 75 inches cubed, and it holds 17, I'll just call them GB gumballs. How many large gumballs would be in a jar? That is 300 inches cubed, and we don't know how many. So when you set up your ratio, so we've got a proportion of two ratios, you are going to cross multiply. So the bottom multiplies by the top. So we're going to drop the units for now, 75x, and then we're going to cross multiply again. 300 times 17 is going to give us 5,100. Then from way back, you remember, okay, if I want to isolate a variable, I'm going to divide by that number, so that would leave us with x equals 5,100 divided by 75, which is going to be 68, and we're talking about gumballs, so that means the larger one would not only hold 17, it would hold. All right, so from there, we're saying, well, can we take those same ideas of setting up a proportion and figure out the number of people in a large crowd? So if you look at your notes, you see that we have a picture of a United crowd. If you've ever been into an Atlanta United game, they're awesome, tons of fun, but there's a lot of people right there, specifically in the section where they're always waving the flags and all that. So if we are saying, let's take a certain amount of the area. So in our example right here, it's saying take the 5 by 5 feet. So you're just taking a certain, like a chunk or a little bit of where people could stand. And we've got that's feet. So 5 feet times 5 feet. If we're trying to find the area, we know we multiply, so 5 times 5 is 25 square feet. All right, so that's nothing like groundbreaking, you know that. But if we are going to estimate the number of people, I don't know, let's say maybe there's 15 people. maybe 15 people can stand in that area, which if you're at a Breaking Benjamin concert at the Roxy, your shoulders are shoulders, you're banging, so you might be able to fit 15 people in there. Maybe not comfortably, but they could fit. So we'll just go with that for now. It's just an estimate. We don't know. You could have picked the number 10 or 5 and all that would have worked out too. So let's take this and apply it to, what if we're looking at, well, let's factor our ratio, or excuse me, divide our ratio. So 15 divided by 25, that's going to give us 0.6 people per square feet. All right, so 0.6 people per square feet, or square foot, excuse me. When we have that, let's say, what if we are watching the Buccaneers won the Super Bowl last year, so like it or not, Tom Brady got another one. So let's take this example. So they're out there on the road. So this is not when they were throwing the trophy back and forth. This is on the road. So the 10 feet deep is what we're saying the crowd has room for. And they were 1 mile long. If you remember our conversion from up above, 1 mile is 5,280 feet. So that's both sides of the road. People are lining up to see last year's Super Bowl champion. So we'll see who wins it this year. Falcons are a bit of a long shot, but we'll see. All right. Then we're saying, well, we need to know how big that space is. So much like above, we did 5 times 5, and we were able to get 25. Here we do 5,280 times 10. So you just move the 0. We got 52,800. And that is going to tell us the amount of area that we have on one side of the road. All right, remember there's people on both sides of the road, so we're going to have to take account for both sides of the road. So if we take our ratio, this was the one we came up with, that may or may not be accurate, we're trying to see, and we multiplied that or set it up as a ratio, so this would be over 1 times our 0.6 people over feet squared, and this was square feet. All right, so we're doing 52,800 times 0.6. All right, so when we do 52,800 times 0.6, then that would leave us with, I'll just write it up here, 31,680 people. All right, and that's on one side of the street. So if we have both sides of the street with 31,000, so we would take our 31,680, multiply it times 2, so that leaves us with 63,360 people that can fit total. All right, that's a lot of people in a small amount of area, but what we're saying is we think that's what it is. If we're going 15 people, and maybe if you're at a concert that stretched that far and you're banging shoulder to shoulder and all that, just enjoying life, then maybe that could fit. But the general rule of thumb is using 2.5 square feet per person to comfortably fit there. All right, so you may be able to fit more, but to comfortably fit to estimate the size. So we still know that we've got our 52,800 now. So if we take that 52,800, and that's what we're saying the square footage is. So just for one side, and we use our ratio that we now know is 1 person per 2.5 square feet. Then we are dividing, basically, is what we're saying. So 52,800 divided by 2.5, and that is going to give us 21,120 people on one side of the road, and then we'd have to multiply that by 2, and that would leave us with 42,240 people on both sides. All right, so that's how we work these proportions to figure out, to take a small segment, use, in this case, approximately 2.5 square feet per person, and it gives us a fairly accurate depiction. All right, so that's video 1, and then you'll see video 2 in a moment for today's lesson.